Hey guys, Mr. T here, just doing a video for the 2019 Practice Year 10 Indices and Linear Relationships test. So this test starts off with index laws, because your first couple of weeks you did index laws revision. So simplifying using index laws. The first rule, you can see the same base number, they're being multiplied at different powers, so you're using the rule a to the power of x times by a to the power of y is going to be a to the power of x plus y. So in this case it's going to be k to the power of 5 plus 3, which is going to be k to the power of 8. Moving on, you've got the same thing. It's x to the power of 6 plus 3, so it's going to be x to the power of 9. Here we've got a different rule. This rule is the base number to the power of any number, say x this time, to the power of y itself becomes the base number to the power of x times by y, which you write as xy in algebra. So here it's going to be that base number to the power of 6 times by 8, which is going to be m to the power of 48. Moving on, this is the same rule now. So base number of a to the power of 3m being multiplied by that power on the outside of the bracket of 4. So that's going to be a to the power of 3m times by 4, which is actually going to be 12m. Moving on, using a different rule again. So this rule is the base number to any power divided by that same base number to a different power is going to be the base number to the power of the first power minus the second power. So here the base number is p. It's going to be the power of 6, and it looks like there's no power of p on the bottom, but it's to the power of 1. So it's going to be 6 take 1, so it's going to be p to the power of 5. Using the same rule again, but now it's slightly more complicated, but use the same rule. Is t to the power of 3m on the top, take away. Looks like t has no power there, but it is to the power of 1. Because you can't do anything between the 3m and the 1, you just leave it. So that's the first page done. Moving on. So now slightly more difficult index laws. Maybe using more than one step. So this is multiplication, same base number, so you're adding the powers together. But now you have pronumerals to deal with. So this first one, I'm going to write it out in full what this means. It means 5 times by c to the power of 3 times by 3 times by c to the power of 4. The order of multiplication doesn't matter, so this means the same thing as 5 times by 3 times by c to the power of 3 times by c to the power of 4. And so you can solve it to be 5 times 3 is 15, and c to the power of 3 plus 4 is 7. Next, using the same rules, doing it a bit quicker, less steps. 4 times 2 is 8. Base number of b, and 2 plus 3 is 5. So 8b to the power of 5. Using the division rules, 14 divided by 2 is 7. X to the power of 5 over x to the power of 2 is going to be x to the power of 5, take 2, 3. Y to the power of 2 divided by y to the power of 1 is going to be y to the power of 1, so you just leave it as y. 24 divided by 15. 3 is going to 24, 3 is going to 15. It's going to be 8 on 5. T6 over T6 cancels itself out because any number divided by itself is going to be 1. It doesn't cancel out to 0, because if it cancelled out to 0, you'd multiply everything by 0 and there'd be nothing left. So here we've just got the r's to worry about. R to the power of 4, take 2 is going to be r to the power of 2. Now we have to remember this rule here, because you've got brackets on the outside of a set of fractions, so that's a slightly different rule than we used before. A over b to the power of anything, power of x in this case, is going to apply that power of x to both the top and the bottom lines. So that helps us remove the brackets here. It's going to be 3p squared over q take q to the power of negative 3 also squared. So now another rule is used where it's the product of two numbers inside a set of brackets to the power of anything. That power is applied to both things in the brackets. So it's going to be here 3 squared and p squared over on the bottom is using the normal brackets rule. It's going to be negative 3 times by 2, so it's going to be to the power of negative 6. So we've dealt with the bottom, we haven't dealt with the top yet. 3 squared is going to be 9, and then p squared is left over q takes 6. Q to the power of negative 6. And then we can't cancel that any further because the base numbers are different. You've got p on the top, q on the bottom, so just leave it. To this last one, use the bracket expansion again. It's going to be a squared to the power of 3 over 5b to the power of 3, all to the power of 3. So it's going to be a to the power of 2 times that 3, 6 over 5 to the power of 3, b to the power of 3, a to the power of 6 I can't do anything with, but 5 to the power of 3, 5 times 5 is 25, times 5, 125, b cubed left over. So that's page 2 done. Alright, so straight after that, the main point of the year 10 stuff was to go over gradient, linear relationships. So state the gradient of the following lines. So the gradient is the rise over the run, where I was more specific. It was how far the line went up or down over the distance it went to the right. So it went up by 2 when it went across to the right by 1, 2, 3, 4, 5, 6. So the gradient is 2 on 6, which is the same as 1 on 3. Here it's gone down by 3 when it went across by 2. So the gradient is negative 3 on 2. Here it's gone across by 1 and it went up by 4, so gradient is going to be 4 over 1, which is the same as 4. And lastly, here it's gone down by 4 and across by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Across by 10, so the gradient is equal to negative 4 over 10, which is the same as negative 2 over 5. Find the distance. So you've been given the distance formula. You'll have a cheat sheet. I'm not using a cheat sheet. Just remember this because you practice. If you haven't done any practice, you won't remember it. If you practice enough, you should be able to remember it anyway. So the distance formula I'll give you here is x2 take x1 squared plus y2 take y1 all squared, which is essentially Pythagoras rearranged. So st, x2 is negative 1, and you're taking 7. And you're squaring that, plus y2 is 1, and you're taking negative 2, and you're squaring that. Deal with the brackets now. Negative 1 take 7 is negative 8 squared, plus 1 take negative 2 is going to be 1 plus 2, which is going to be 3, and you're squaring that. My working out doesn't fit, so I'll move it up. Negative 8 squared is 64. 3 squared is 9. So your answer is going to be the square root of 73. It doesn't ask you to do as a decimal, so you leave it at square root of 73. Determine the midpoint of ST. The midpoint formula is the coordinates of the midpoint are x1 plus x2 divided by 2. That's the x coordinate of the midpoint, and y1 plus y2 over 2 is the y-coordinate of the midpoint. So x1 in this case is 7 plus, and you're adding -1, which is x2, dividing all that by 2, comma. y1 is -2, and you're adding 1 to that, divided by 2. Continue the working here. 7 plus -1 is 7 take 1, which is 6, divided by 2, comma. -2 plus 1 is going to be -1 on 2. The 6 on 2 can cancel down to 3, comma. So it's 3, -1/2 is the coordinates of the midpoint of ST. Find the gradient of the line ST using gradient formula. So the gradient formula you need to use when you have the points and you don't draw it. The gradient formula is y2 take y1 over x2 take x1. y2 for ST is going to be 1, and you're taking y1, which is -2, over x2 is -1, take, and x1 was 7. 1 take -2 is 3, -1 take 7 is going to be further -8. So that is the gradient of the line ST. State the gradient of all lines parallel to line ST. Parallel means they have the same slope. So parallel lines have same slope, therefore gradient of 3 over -8, which is what we worked out in the previous question. Right, so that's that page. Moving on. State the gradient of all lines that are perpendicular to line ST. So perpendicular means that the lines have a gradient that's a negative reciprocal. Have negative reciprocal gradient. Therefore, it's going to, before it was -3 on 8, now it's going to be not negative, because the negative and negatives are positive, and flip the fraction over 8 on 3. Consider the points P, 2, 7, Q, 7, 4, and R, -4, -3. Find the gradient of PQ. So we used the gradient formula already. Gradient is equal to y2 take y1 over x2 take x1. 4 take 7, 7 take 2. It's going to be -3 on 5. Find the gradient of QR. Gradient is going to be y2 -3 take y1 4 over x2 -4 take x1 7. -3 take 4 is going to be -7. -4 take 7 is going to be -11. And negative divided by negative is going to be a positive, so the gradient is going to be 7 over 11. State the gradients of all lines perpendicular to QR. Well, gradients perpendicular to QR is going to be the negative reciprocal, which is going to be negative, because the negative or positive is negative, -11 over 7, because I flipped the fraction over. Show that the triangle PQR is a right angled triangle. So there's two ways to do this. I'd like you to show you both, to show you that maths is kind of cool, and as long as you do the maths correctly, it doesn't matter which way you do it. So I'm going to show you Pythagoras Method, which is the intention of the question. You do it Pythagoras' way, but based on the stuff that we've learned, you should be able to do it the other way too. So PQ, if you work out the distance, the length of PQ is going to be 7 take 2 squared plus 4 take 7 squared. So 7 take 2 is going to be 5. 5 squared is going to be 25. 4 take 7 is going to be negative 3. Negative 3 squared is going to be 9. So this answer is going to be the square root of 34. 25 plus 9 is 34. That's PQ. Now, that's one side of the triangle. QR is the other side of the triangle. Its distance is going to be the square root of negative 4 take 7 squared plus negative 3 take 4 squared. Negative 4 take 7 is going to be 11. Negative 3 take 4 is going to be 7. So 11 squared is going to be 121. And 7 squared is going to be 49. So QR is going to be the square root of 121 plus 49 is going to be square root of 170. And then the last side of the triangle, R, not RQ, it's going to be RP, is going to be the square root of 2 take negative 4 squared plus 7 take negative 3 squared. 2 take negative 4 is going to be 6. 6 squared is going to be 36. 7 take negative 3 is going to be 10. 10 squared is going to be 100. So, RP is going to be square root of 100 and, not 100, square root of 100 and add 36, 136 long. So now, we have the three sides of the triangle. There's two shorter sides here, square root of 34, square root of 136. So if it's a right angled triangle, it should make the a squared plus b squared is equal to c squared phenomenon true. So let's see if it does. Square root of 34 squared plus square root of 136 squared is equal to, what is it equal to? Well, the opposite of square rooting something is squaring it, so you're going to have 34 plus 136 is going to be 170, which was what c squared is going to be. So, therefore, PQR is right angled. The other way to do it is using gradients. And you can do this because it's been taught to you. So, gradient of RP is going to be 7, take negative 3, over 2, take negative 4. Oh, there should be separate brackets. That's going to be 10 on 6, which is the same as 5 on 3. Now we already worked out that PQ gradient was negative 3 on 5. RP has a gradient of 5 on 3. They are negative reciprocals. They are therefore perpendicular. Therefore, PQR is right angled based on another bit of information as well. So that's that page, using two different ways to solve that question. Moving on. Given the information below, find the equation of lines in slope-intercept form. So slope-intercept form, if I can remind you, is y is equal to mx plus c, where m is the slope and c is the y-intercept, where it crosses the y-axis. So, if it's got a gradient of negative 2, the slope is going to be negative 2. Write the x there, and it's got a y-intercept of 7. So, if it crosses 7, you're adding positive 7 to it, so you leave it at that. With a gradient of 3 on 2 and passing through the origin 0. So this is trying to trick you by not having a clear y-intercept, but the origin, the y-intercept, is at 0, because the origin is at 0, 0. So the gradient is 3 on 2, x, and you're adding nothing, so that is the equation. On the grid below, draw the graphs of the lines with the following equations. Okay, so you're going to need axes. So I'll try to draw them as best I can. Don't have a ruler in this. Just need to ask them to be quiet. Just give me a second. Right, continuing on. Draw the origin here. Arrowheads to show that they continue forever. So, I'm going to draw A in red, B in blue, red, RBG, C in green. So, red has a y-intercept of -4. So, 1, 2, 3, -4. It crosses the y-axis. And then it has a slope of 2/3. So, it goes across by 3, 1, 2, 3, up by 2 every time. So, line A goes through those 2 points. Like that. That is line A. Line B in blue. It has a y-intercept of -1. Based on that information, it goes, well, it has a slope of 3, which as a fraction is 3/1, so it goes across by 1, up by 3. So it goes through those 2 points. So, not the easiest to draw lines here, no ruler. The screen is slippery, but I got it. So that is B, and then C is in general form. So I need to do some stuff to be able to draw it using slope-intercept form like you've learned about. So I'm going to move the 3x's over to the right. The opposite of positive 3x's is to take 3x's, so I'm going to take 3x's from both sides. So it's going to be 1 take 3x. Right now that doesn't look like slope-intercept form because the negative 3x is in the wrong place, so I'll move it to the front, -3x. And what do I have left over on the right? A +1. It's still not in slope-intercept form because it has to be as no pronumerals in front of the y, so I'm going to divide everything by -2 because -2 is multiplying y. So divide everything by -2. It's going to be -3x on -2, and it's going to be +1 on -2. Put the working out down here. So y is going to be, well, a negative number divided by a negative number is positive 3x on 2. And 1 divided by -2 is going to be, well, -1 on 2. So now I can draw the line. Mark the y-intercept, which is going to be -1/2. So here. And it goes across by 2 and up by 3. So 1, 2, 3. So now I can draw the line through these dots. Try it carefully. There we go. So that is drawn. That is C there in green. So that's that page done. Moving on. State the equations in slope-intercept form of the lines drawn on the grid below. So you have 3 lines here, one in red. So the red one crosses the y-axis at -1, -2, -3, -4, -5, -6, -7. So it's going to have the equation y is equal to something x, take 7. Now we need to work out the slope. So it goes, I'm just going to choose a point here. It goes across by 1 and down by 1. So it's going to have a slope of negative 1 over 1, which is going to be negative 1. So negative 1x is the same as negative x. So negative x takes 7. Equation of b, which is in green, it cuts the y-intercept at y. It has no slope, so its equation is going to be y is equal to 2. No x term there. Line C, it crosses the y-axis at 1, 2, 3. So it's going to have an equation of plus 3 of some description. What is the slope? Well, it crosses at 3, it goes across by 1, 2, 3, goes up. No, it goes across by 4 and up by 3 to hit that point there. So it's going to have a slope of 3 on 4. So the equation is going to be y is equal to 3 on 4x plus 3. Rearrange the following equations in slope-intercept form into general form. So I need the variables x and y both on the same side. Right now, 3x is on the right-hand side. So the opposite of positive 3x is negative 3x. To balance it out, I need to do the same thing on the other side. Negative 3x on this side. So what do I have? I have negative 3x plus the y on the left-hand side is equal to, well, 3x take 3x is going to be 0. So all you have left is negative 4. And you're done. Here we've got fractions trying to confuse you. And it's more complicated because general form's got whole numbers, but do the same thing as last time. Negative 6 on 7x, the opposite of that is adding 6 on 7x. Need to do that on both sides to balance it out. So you've got 6 on 7x, add y is equal to negative 6 on 7x plus 6 on 7, nothing left. So 5 on 7 on the right hand side. Now the problem is the fractions. You are dividing by 7. So to get rid of dividing by 7, you need to times everything by 7. 6 on 7x times by 7 is going to leave you 6x. Y times by 7 is going to be 7y. And 5 on 7 times by 7 is going to leave it at 5. So that's done. Lastly, opposite of 4 on 9x is going to be negative 4 on 9x. Take 4 on 9x on both sides. So you're going to have negative 4 on 9x plus y is equal to 4 on 9x. Take 4 on 9x is going to be 0, so all you're left with is positive 2 on the right hand side. The fraction is giving you problems. To times everything by 9, you're going to have negative 4x plus 9y is equal to 2 times 9, which is going to be 18. That's that page done. Rearrange the following equations in general form to slope-intercept. So back the other way we need to go. So right now these have variables on the left hand side. I need y on the left, x on the right. So to get rid of positive 2x, I need to take 2x and do it on both sides to balance. Negative 2x plus 2x is going to be 0, so all you've got left on the left is 5y, is going to be 10, take 2x. That's not quite in the order I want, so rearrange it. The right hand side has a positive 10 and a negative 2x, so I'll move the negative 2x first and have the positive 10 after. That looks more like slope-intercept form. Now I need to get rid of this 5. 5 is you're multiplying y by 5, so the opposite of multiplying by 5 is dividing by 5. I need to divide everything by 5 on both sides. To remove the 5, 5 over 5 is going to be 1, so you're going to be left with y. Negative 2 over 5 is not doesn't cancel down, so you've got negative 2 over 5x plus 10 over 5 does cancel down to 2. So similar process on the second one. I need to take 6x from the left hand side and the right hand side to get rid of the positive 6x. You're going to have negative y left over on the left hand side. 1 take 6x. It's not in the right order, so rearrange to negative 6x, add 1. I need to get rid of the negative in front. Now remember, anything with a negative sign is the same as negative 1 times by that thing. So I've written that to show how I'm going to cancel out the -1. What is -1 doing to y? Timesing. So I divide by -1 everything to get rid of it. So -1 divided by -1 is going to be 1. Y is left over. -6 divided by -1 is going to be 6x. And +1 divided by -1 is going to be -1. Alright, this last one, to get rid of positive 9x, I take 9x from both sides. -9x plus 9x is going to be 0, so you've got -2y on the left-hand side. -5, take 9x. Rearrange to have in slope-intercept form. -9x, take 5. Get rid of the timesing by -2 by dividing everything by -2. Cancels. Y is going to be -9 divided by -2. Doesn't cancel down, but it does make a positive. Take a -5 over -2 is going to be +5 over 2. So that is that page done. So a few worded problems using your linear relationships knowledge in a more realistic context, graphing context. This graph shows the relationship between time it takes an electrician to complete a job, which you can see along the x-axis. The longer it takes, the higher the cost, which you can see on the y-axis. So find the gradient and c-intercept of the line. C-intercept meaning y-intercept. Why is it c? Because c is the y-axis here. So the c-intercept there is there. We need to work out what these markers mean. So there's 1, 2, 3, 4, 5 markers for 100. 100 divided by 5 is 20. So each of these represents 20. 20, 40, 60, 80, 100. So A, the gradient. How do we find the gradient here? The gradient formula is y2 take y1 over x2 take x1. We need to find a y2 and a y1. We need 2 points, so I'm going to use this point. y2 is at 100. So it's going to be 100 take y1, which is the first point. It's going to be 40 over x2, which is 1 take, it started off at 0. 100 take 40 is 60 over 1 take 0 is 1. So it's going to have a gradient of 60. C-intercept, which is the y-intercept, is going to be where it crosses the y-axis, which is at 40. What does this mean? Well, interpreting this answer, it means that cost increases by $60 every 1 hour. That's given by the gradient. Job starts at $40 because with a job time of 0, it still costs 40. So when they come out, you're still going to pay the electrician $40, whatever they do, however long they stay for. Okay, so that's interpreting the x and y intercept here in this question. B, find the cost of a job that takes 3.5 hours. So 3.5 hours is going to be here. I simply look up. That's halfway between two of the markers, but we know the markers are 20 each, so that must be 10. So it's going to be 200, 220, 240, 240 plus 10, 250. So a 3.5 hour job is $250. Oop, I've written there for no reason. I was trying to move my little guard down. C, if the cost of a job is 130, how long did the job take? So we go the other way. We look for the price, 100, 120, 130 here. I go across to the line, and you can see it lines up with between 1 and 2, which is 1.5. So $130 job would take 1.5 hours. That's question 11 done. 2 more to go. Table alongside uses conversions. This shows a conversion between degrees Celsius and degrees Fahrenheit. So A, draw the graph. So This is combining some of your science, some of your statistics knowledge from last year. You can't escape it. You need to do it all in one. That's what STEM is about. So drawing a graph, take up as much space as possible in the grid below. It moved a little bit, but that doesn't matter. You'll have a ruler when you're doing your tests. I do not. And if I did have a ruler, it would slide around anyway. So I've drawn my axis lines. Decide on the scale. Temperature, Celsius. I'll put along the bottom. Because, why? Well, we're converting, and the number of degrees Fahrenheit is going to depend on the number of degrees Celsius in this situation. So I'm going to put 10 after 5 blocks. 20, 30, and this represents degrees Celsius. The other side needs to go up to 86, so the best I'll probably be able to do is 10, 20, 30, 40, 50, 60, 70, 80, 90. This represents degrees Fahrenheit. So plot the points, 10 to 50. That's there. 20 to 68. 20, 60, 65, 67.5, 68 is going to be somewhere just up there. 30, 86. 30, 80, 85, 86. So I plotted the points. Did the variables appear to be linear related? Explain your answer. Well, how can I tell if they're linear related? I should be able to draw a line through them. That's what linear means. So that's pretty linear, because I can draw a line, pretty much draw a line through them. So that's B done. C, find the gradient of the line and interpret your answer. So to find the gradient, I need a point 1. Oh, that's a point 2, sorry, and a point 1. So C, gradient is going to be y2. y2 is at 86 minus y1, which is at 50, over x2, which was at 30, take x1, which is at 10. 86 take 50 is going to be 36. 30 take 10 is going to be 20. 36 over 20 is 18 over 10. Cancels down further to 9 over 5. Because 18 divided by 2 is 9, 10 divided by 2 is 5. Find the gradient line, interpret your answer. So what does this mean? Means every 5 degrees Celsius increase is a 9 degrees Fahrenheit increase. So that's what the gradient means in this particular context. D. Water freezes at 0. Find the freezing temperature of water in F in degrees Fahrenheit. So how am I going to do that? Well, the freezing temperature Celsius is there. It's along the y-axis. I just need to work out where this line crosses the y-axis. So I'm just going to extend that line. I probably shouldn't have started there. Should have started further up the line, so it's more accurate. That's better, so I can tell if it's around 30. It's not going to be exact. It's approximate because you're reading it off the graph, and it depends on your drawing. But my answer to this on graph, approximately 30 degrees Fahrenheit. is the freezing temperature of water. Now E, a weather bulletin from the United States reports that the temperature in Miami is 100 degrees Fahrenheit. Use the graph to estimate the temperature in degrees Celsius. So again, we're extending the line. So I'll extend the line part way into it. Nope, that's not a straight line. That didn't start on the blue. That's better. So I extend it until it's up to where 100 is going to be. Just around there. So I need to construct. 100 is going to be here. 100 is going to be here. So across and then down from there. I can't do dotted lines. It's going to go through my writing. So draw a vertical line and move it afterwards. So it looks like it's going to be around 30, 32, 34, 36, 38, 40 here. 30, 36, 37, let's just say 37 and a half. So E, approx. 37 and a half degrees Celsius, red on graph, so that's why it's approximate. It's relying on the drawing. So that's that question done. Last question. Average non-smoking Australian, life expectancy of 84, estimated for long-term smokers. Each cigarette reduces a person's life by half a year. Copy and complete the table. So, first thing, life expectancy of 84 years without smoking. So, that's going to go there. Now, I need to work out, well, it's going up by 5, so I can't just take 0.5 from that. Well, 5 lots of 0.5 is going to be 2.5. So, if I reduce 84 by 2.5, it's going to be 81.5. A further 2.5 is going to be 79. A further 2.5 is going to be 76.5. A further 2.5 is going to be 74. So that will fill out the table of life expectancies. Draw the graph of y is against x. So doing that again. First axis, second axis, decide on the scale. We could go all the way 5, 1 per box, 10, 15, 20. Life expectancy, we can't do 1 per box here, we'll do the same as last time. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Draw the graph, so plot the points. 0 is at 84, 85 is here, so 84 is going to be slightly below. 5, 81 and a half. So 5, 81 and a half is going to be somewhere there. Not perfect, but close enough. 10 is going to be slightly less than 80. 15 is going to be 76 and a half, so more than 75. And 20 is going to be 74, so under 75. So once again, that appears to be a linear relationship. Might as well draw a line through it all now. way across. Move it sort of close. It's not quite the right angle, but you get the picture. So I've drawn the graph, I've drawn a line through them. So B, draw a graph, C. Find the equation connecting the variables. So equation is y is equal to mx plus c. That means I need the gradient and I need the y-intercept. I already have the y-intercept. Y-intercept is at 84. I need the gradient, so I need 2 points. I'm going to start off at 0, 84, and I'm going to end at 20, 74. So the gradient is going to be 74 minus 84, where it started, over x2, which was 20, minus x1, which is 0. 74 take 84 is negative 10. 20 takes 0 is going to be 20. So the answer is going to be negative 1/2. So the equation is going to be y is equal to negative 1/2 x plus 84. That is C done. D. Find the life expectancy of an Australian female who smokes 25 cigarettes per week. So 25 is going to be 1, 2, 3, 4. It's going to be here, 25. Using my graph, draw a line up. So it looks like it's going to be around 71 or so. It's above 70. But you could answer that. You could say D on graph, approximately 71. Or you could use algebra, because you've got the equation. Y, what is Y going to be when someone was smoking 25 cigarettes? So replace X, which represents the number of cigarettes, by 25 plus 84. What's a half of 25? That's 12.5. So negative 12.5 plus 84. It's actually going to equal 71.5, which is pretty damn close to that, which I read off the graph. So I've drawn it pretty okay. So 71.5 years. E, an Australian female has a life expectancy of 80 years. How many cigarettes does she smoke per day? So 80 is here on the graph. So going across, looks like it's going to be like 5, 6, 7, 8. It looks like it's going to be 8. Okay, so based on the graph, if you look down on graph, approximately 8 cigarettes. But that's not sure, okay? That's based on the line drawing and being accurate. We can use the equation to work that out. So instead of 84, now we know that the life expectancy was 80. Y represents the life expectancy. So if we put 80 as y in the equation, and you've got the rest of the equation is negative 1/2 x plus 84, we can rearrange to work out what x should be when the life expectancy is 80. So, opposite of add 84 is take 84. If I take 84 from both sides, you're going to be left with negative 4 on the left-hand side is equal to negative 1/2 x. Now you're probably wondering what to do here. Well, I can rewrite it in a more familiar way. Negative 1/2 of something is the same as negative of the thing divided by 2. That means the same thing. So now you can clearly see what's being done to negative x. It's being divided by 2. What's the opposite of dividing by 2? Timesing by 2. So times both sides by 2. That's going to cancel out. So negative x is going to be equal to negative 8. And if negative 8 is equal to negative x, well, 8 is going to be equal to x, which agrees with our approximate found by looking at the graph. So therefore 8 cigarettes for someone with a life expectancy of 80 years. So that is the complete practice test. Hopefully that helps you out with the thinking, explaining how to work your way through these kind of questions. And I'll see you in the next video.